Alright, today we are going to talk about similar figures. We're going to start in with similar triangles as our example and then work our way through. Please pay attention, take really good notes, make sure that you are not skipping over things because this is going to set us up for what we're doing for the rest of the unit. Alright, so jumping right in, up here in this right hand corner, we've got this symbol right here. So we're going to go ahead and we're going to do the wavy symbol that you usually see on top of congruence is the symbol meaning similar to. Alright, so you get rid of the equal sign and you just have the wavy part from the top of the congruent symbol. That little wave means that those things that you're comparing are similar to one another. So we're going to go ahead and we're going to do an example. I'm going to ask you to have 3 colors of highlighter. So 3 colors of highlighter will help you color code what's going on in these shapes and take it one step at a time. For similar figures, they have to have 2 things. One is corresponding angles, which are congruent. Okay, and what that means we'll go into way more detail of, but just like with corresponding angles in our parallel lines, those are the angles that are in the same position in the different shapes. And so when we've got those angles that are in the same spot in the different shapes, those angles need to be equal to each other, because remember, congruent means equal. Okay. The second criteria for similar figures to be similar is that corresponding side lengths form equal ratios. Okay. So we've got 2 criteria there. Criteria number 1 is that corresponding angles are going to be congruent and corresponding side lengths are going to form equal ratios. So there's our 2. And now we're going to go into detail of what those things mean. Remember, if you need to slow the video down, you can, or speed it up, but I'm just going to go slow and steady. So what we're going to say for similar figures, we're going to put a little note to ourselves. So draw a little star here. And you're going to say basically similar figures are the same shape, but different size. Okay, so for things to be similar, they need to be the same shape, but different size. So now we're going to look at these 2 similar triangles right here. We're going to talk about how you write a similarity statement and what makes these 2 triangles similar. And I'm going to try to color code it the best that I can to really help you focus in on the details. So we've got 2 triangles. We can see right now that they look pretty much the same shape. Okay, they're looking like they're about the same shape, but hopefully when you look at this, you notice that this triangle right here, triangle ABC, is smaller than triangle FGH. They have basically the same sides, but just this one's longer than this one, and so on and so forth. So we're going to say that triangle, and we use a symbol of a triangle in front of our letters to symbolize we're talking about the triangle right now. Triangle ABC. So ABC, use all 3 vertexes. Okay? So triangle ABC is similar, that's our similarity symbol, to triangle FGH. And when we name the statement, we're going to put the letters of the corresponding parts in the same spot. So A is in the same spot as F because those are corresponding angles. Okay, B is in the same spot as G because those are corresponding angles, and C is in the same spot as H because those are corresponding angles. So it is important what order you put the letters together when we're making similarity statements. So if I come over here, I'm going to go ahead and talk about angle A. If we are looking at this, I'm going to say that angle A is congruent to angle F. And you'll be able to tell that angle A is congruent to angle F because we've got these matching arcs here. Okay? To make a statement, a congruent statement there, I would write that as angle A is congruent to angle F. Okay? And then I'm going to give you some more information. So I'm going to draw two arcs here for B, and I'm going to draw two arcs here for G. And we know if they have the same number of arcs, they're also congruent. So I'm going to say that angle B is congruent to angle G. And I'm going to pause and just remind you those angle symbols are mandatory. Some of you guys have been losing points on your assignments because you're not putting the angle symbols, you're just putting the letter. So don't kind of rush through it and leave out the important details. All right, and then last but not least, angle C. We're going to put 3 arcs in it. And we're also going to put 3 arcs in H because these two angles are also congruent to each other. So I would say angle C is congruent to angle H. That part's pretty basic. We're just remembering to use the right arcs, and that would be information that's given to you or that you're asked to prove. But now we need to talk about the side lengths because form an equal ratio might sound a little odd to you, and I want to make sure we really understand how to do this. So what I'm going to do is I'm going to make corresponding sides the same color. So I'm going to go ahead over here and I'm going to make the side AB the same color as the side FG because these are the corresponding sides. Notice that A is the 1 arc and B is the 2 arcs. So when I name it, I go from 1 to 2. And over here, same thing. I'm going from 1 arc to 2 arcs. So I'm going to name it FG. Okay. So as I name these, I'm going to go ahead and write AB is compared to FG. And the order that I put those letters matters because I want the A with the F and I want the B with the G. Okay. Then I'm going to take another color. So this is my blue ratios. And I'm going to do the same thing with the other sides. So over here, I'm going to say that BC is orange and GH is also orange. And I'm going to write my statement, my generic statement with the no measurements yet, just the letters. And I'm going to say that BC needs to be over GH. And the reason I went in that order is because B has 2 arcs and G has 2 arcs. So they're like lined up with each other. C has 3 and H has 3. So they're lined up with each other. I'm going to go ahead and highlight those orange. And then I'm going to take my last side and I'm going to go ahead and make it purple. Okay. And on that last one, I'm going from A to C. So I'm going to write AC. And then A is on my 1 arc. F is on my 1 arc. So I want A and F in the same position. Those are the corresponding angles. And then C has 3 and H has 3. So I want C lined up with H because those are my corresponding angles. And I'll highlight that in my purple color. That's kind of dark, sorry. Hopefully you can see that. This one is AC and this one is FH. Okay, now we're going to go in with some more information. I'm going to give you the measurements of these triangles. So the segment AB measures 2, and the segment BC measures 10, and segment AC measures 12. Okay, and then over here, FG is 3, GH is 15, and FH is 18. So now I'm going to go in and instead of writing AB, I'm going to write the measurement of AB. So right here where it said AB, underneath I'm going to put 2. And then I'm going to look for FG, and I see that the measurement is 3. BC is 10. And GH is 15. and then AC is 12, and FH is 18. So just like we did with our proofs, we went in with the generic statement with the names of the sides, and then we go in with the measurements. So we want to get in the habit of doing the letters first, then the numbers. Okay? Now, we need them to form equal ratios. So what we need to be true is that 2/3 is equal to 10/15, which is equal to 12/18. And if you're one of my friends that struggles with fractions, you might be thinking those are 3 different numbers, Miss Alfano. But I need you to remember that 10/15, and I'm going to switch this to the other side and give you a teeny tiny reminder of how to simplify fractions. Not much. So let's take the numbers 10/15 and 12/18 and write them on the back. Okay, so we're going to go with 10/15 and 12/18, and I'll even write 2/3 up here so we can compare. Okay, now 2/3 is already simplified. There's nothing I can divide both 2 and 3 by and get an even answer. Those are both prime numbers. So I'm going to come down here to 10/15, and I'm looking for the greatest common factor. So remember, we have to divide by the G, the GC, not GF. Okay, we have to divide by, that was awful. Divide by the GCF, the greatest common factor. So when I look at 10 and 15, I see that both of these numbers are divisible by 5. So I'm going to divide both the numerator of 10 and the denominator of 15 by 5. 10 divided by 5 equals 2. 15 divided by 5 equals 3. So when I simplify 10/15, it equals 2/3, which means that these two ratios are equal because now I've got 2/3 and 2/3. We're going to do the same thing here. I'm looking for the GCF, the greatest common factor. So I have to think about, what can I divide 12 by? Well, I can divide 12 by 2, by 3, by 4, by 6, by 12. 18, I can do 2, I can do 3, I can't do 4, can't do 5, I can do 6. And then I look at them and go, oh, the biggest one they have in common is 6. So I'm going to divide both of these by 6. I get 12 divided by 6 is equal to 2. 18 divided by 6 is equal to 3. And lo and behold, this one also equals 2/3 when simplified. So all 3 of my ratios are equal to each other. That means that we have similar sides. Okay? So remember, if we come back up here, our 2 criteria where the angles are congruent, which we have, these angles are congruent, these corresponding angles are congruent, and these corresponding angles are congruent, and that the corresponding side lengths form equal ratios. So this set of blue sides is equal to the set of orange sides is equal to the set of purple sides when we simplify those ratios down. All right, we will practice that, and we really want to practice that well because that's going to apply to all shapes. That's not just going to be triangles. It'll apply to rectangles, hexagons, whatever you can think of. The only thing it doesn't apply to, which is our little note right here that we want to take note of, is that all circles are similar. Okay, so every circle you ever see is similar to every other circle you ever see. They're all 360 degrees. They all have the same ratios of their circumferences of pi r squared, or sorry, pi times the diameter, and their areas are all going to be similar. So all circles are similar. Okay. Next thing we need to talk about, how to find the length of a missing side. So we're going to go ahead and form some ratios here. If we know that things are similar and we've got some ratio information, we can solve for an unknown side. So we're going to go ahead and say that we're going to put the missing side here. And you're going to put it in as a variable, just like always. If I don't know something, I'm going to select a letter to represent it. Okay? And then we're going to put that over its corresponding side. And we're going to make that equal to a side we pick from. So pick a side from the first polygon. Remember, polygon is just a fancy way of saying shape. And put that over, once again, its corresponding side. Okay. So here we've got the trapezoids are similar, find x. So they're telling us they are similar. They are not asking us. They are giving us that information. I'm going to go ahead and bump that up for you guys. They are not asking us, are these similar? It says the trapezoids are similar. We know they're similar. Once we know they're similar, we can use that information to solve for unknown information. So let's look at this and see what we know. We know that this bottom side is 24, and this right side over here is 9.4. For here we know the top side is 29, the bottom is 40, and this right side is an unknown. So we need to set up a ratio to solve for x. So we're going to put our missing side, which is x, on top of its corresponding side. So I'm going to write x over, and then what is the corresponding side to x? If I look over at the other shape, is 9.4 in the same position, or is 24 in the same position? Well, let's look at it. 9.4 is this diagonal line, x is this diagonal line. These correspond to each other. So I'm going to put x over its corresponding side. And then I'm going to say that that is equal to, and I'm going to write a ratio of another set of sides. Now, if I look over here, I only have the bottom. Here I have the top and the bottom. And I have to make a ratio of corresponding sides. So I can't pick the top because I don't have enough information. I need to pick the ones where I have both, one from each of the shapes. And I have to put them in the correct order. So since we put the bigger quadrilateral on top over here, I need the bigger quadrilateral on top for the new one. So we're going to put 40 on top, over, and then the corresponding side to 40 is 24. Now I have a proportion, and we should remember back to past grades and assignments that we can solve a proportion using the, you can call it any method you want. I usually just call it cross multiplication. We should know that 24 times x is equal to 9. Can't see my little decimal point there. 9.4 times 40. So I'm going to go ahead and I'm going to make an equation that I can solve with this by saying 24 times x is equal to 9.4 times 40. Probably made a poor choice pushing that stuff so close together. Once again, if you need another piece of paper or something, please use it. Don't get confuzzled. All right, so let's go ahead and grab our calculator because I'm feeling kind of lazy. I'm going to do 24 times x, so the 24x. See, I told you I was feeling some sort of way. I'm going to clear that. And then on this side, I have 9.4 times 40. So 9.4 times 40 equals, and that's 376. Okay, now I need to get x by itself. And you know I'd get a text, right? Well, I'm doing that. I get x by itself by dividing by 24. I already got 376 in there. I don't have to type it again. I can just go divided by, see, 376 divided by 24 equals, and I'm going to get this lovely ratio. We're going to, this is a continuing, ongoing, so we're going to round to the 10th place, and we'll just say x is equal to 15.7. Okay. And if you really want to be accurate, we can make it kind of wavy since we know we rounded. We can say it's almost equal to, it's approximately 15 and 7 tenths. Okay. All right, so let's practice this. We're going to look at our shapes and we're going to see which sides are corresponding with which. This would be the time that I would really strongly encourage you to pause the video and do these problems on your own. I'll keep recording, but it would make more sense for you to try them on your own, see how you do, and then come back and check your work. So I'm going to go ahead and jump right in with problem A. It says find DF. So now I need to locate what they're talking about. So I'm going to kind of highlight that. They want this side right here. And it's an unknown, and I'm boring, so I'm going to make that X. Okay, I need to figure out which sides are corresponding. So I've got bottom and bottom here. I've got diagonal and diagonal here. This one's got the right side, but I don't have the right side over here. So I'm going to not use this 18. I'm going to use the 15 and 10, and I'm going to use the 21 and x. Now, we need to make a ratio of our missing side, so that's x, over the corresponding side. So that's in the other shape, the same side. So DF corresponds with AC. So I'm going to put over 21. And set that ratio equal to the bottoms, because I have both of the bottoms. And it's my choice what I set it equal to. If I had this information over here, I could choose the side or the bottom. So just know it doesn't have to be one or the other. It's whichever one you have enough information. And if you have lots of information, you get to choose. All right, but my x was first, so I have to use the number from that same figure as the top again. So we need to put 10 on top. We can't put 15 on top because since x was on top, we have to have the same shape in the same position. Okay, and then we're going to put 15 there. Once again, we'll cross multiply, so I'll get f, I don't know what I'm saying, 15 times x is equal to 21 times 10. Okay, so I get 15x equal to, I know when I multiply by 10, I just add a 0, so that's just 210. And then I'm going to divide by 15 on both sides. I have a guess what that is, but I'm going to go ahead and check because, you know. Let's see, let's do 210 divided by 15 equals, that gives me 14. Okay, so I have x is equal to 14. Now look and see, is that what they asked me for? It is, but they asked me for DF, so if I wanted to be more careful on what they're looking for, because a lot of times our computer assignments and questions, they want it super specific. Let's come back, since it said find DF, let's go ahead and say DF is equal to 14, and then let's use our unit of measurement. We're talking about centimeters. Okay, so let's go ahead and make our answer. DF is equal to 14 centimeters. We want to make it as accurate as possible so they can't mess us up on small details. Okay. All right, hopefully you did this next one as well. It says find AC, so I'm going to go ahead and highlight that so I don't get confuzzled again on what I'm even looking for. Over here, AC is my smaller side. See these longer sides? So even though this is switched around, I'm not going to look at the right side over here, because the right side, the AC is definitely not the same as at EF. So there are times they're going to move things around, they're going to rotate them, they're going to flip them, and you're going to have to look and go, well, which ones actually match up? So in this one, I would be matching up my AC with my FD. Okay? And then I look at the information, and down here I've got 24. I don't have that bottom piece over here. I do have this diagonal, so I'm going to match up my 30 with my 75. Okay? And there's not a lot of room on here, so I'm going to flip this over, I think, just to give us better space and remind you, you do not have to squish everything into small spaces. So my unknown, let's just make it x again. So I'm going to do x over 18, and I got to do this shape first if I do my x first. So x over 18, and then 75 over 30. So let's see if I can remember that. X over 18 equals 75 over 30. So please don't get locked into having to smush everything. All right, so we're going to cross multiply. We're going to take 30 times x, which is 30x, is equal to 18 times 75. Once again, I don't know that off the top of my head, so I'm going to do 18 times 75 equals, it's 1,350. Bring everything else down. And then to get x by itself, I'm going to divide by 30. And if you did what I did and you didn't touch the calculator in between, you still have your 1350 there. So you can just do divided by 30. Okay. Look at your screen. Make sure you actually typed what you think you did. So here we got 45. So I have x is equal to 45. So I'm going to remember that. X equals 45. I'm going to flip it back over. I'm going to come over here. I'm going to say x equals 45 so I don't forget. And then see what it asks. It asked me to find AC. So we're going to go ahead and say AC is equal to 45. And then this one didn't give me a unit of measurement. So I can't put centimeters or inches because it didn't tell me. So I'm going to just leave it as AC is equal to 45. We don't know what the unit of measurement was. Okay. All right, next one, it says the triangles are similar. Find the ratio of the side lengths in simplest form. So this is going back up to that beginning here where we're going to get those ratios and then we're going to have to simplify our fractions. We have to figure out which sides are corresponding to which sides. So for me, visually, I can see that the 4 and the 6 go together. And if that's the case, then I'm going to go ahead and go with the 6 and the, there's nothing there, go together. And then I'm going to come over here and say, well, this 6 goes with this 9. Now I want you to think about this. If they're similar figures and their ratios are similar, then 6 goes with 9, means that this 6 also has to go with 9 because they can't make equal fractions if we've got 6 over 9 and then 6 over something else. So by looking at this, seeing this as an isosceles triangle, we know that its similar triangle is also going to be isosceles, which tells me this is 9. Okay, and so my ratio, we can go 6 over 4. Oops, sorry. We're going to go orange over orange, right? So 6 over 9 is equal to, let's go purple over purple. So that's 6 over 9 again. And then blue over blue, which is equal to 4 over 6. So did you see how I could oops and draw the ratios wrong? Which is why having those colors before you get started can really save you from making some silly mistakes. Let's see if 6/9 and 4/6 equal each other. Let's come back over here to the other side. I've got 6/9 and 6/9 and 4. I think it was 6, but let's double check. Yep, 4/6. And I want to see, are these ratios equal to each other? Well, what do 6 and 9 have in common? They have in common 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So this one's 2/3. 6, 9, that's the same thing. So this one's 2/3. And then what do 4 and 6 have in common? Well, they're both even numbers, so they're divisible by 2. So I get 4 divided by 2 is 2. 6 divided by 2 is 3. The ratio is 2 to 3. So over here it says find the ratio of side lengths in simplest form. Simplest form is the key. We don't want to leave it as 4/6 or 6/9. We want to simplify it. So in this case the ratio is 2/3. We'll put a little box around it and call it a day. All right, example D, we're going to do the same thing. Let's look at this and let's go ahead and say, I know that 24 is going to go with 18. And I know that 12 is going to go with, I have no idea. So we have to find the side length before we can find the ratio. Or do we? So this is one of those moments where some of you guys do some extra work, and it would be me. I would fall into that category when I was younger. I would have solved for this missing side. But let's look back at the question. It said the triangles are similar. We already know they're similar. I don't have to prove it. It says find the ratio of the side lengths in simplest form. Well, if you remember, the ratio for all the side lengths is equal to each other, right? So I don't need more than one. I only need one set. So I need to just make a ratio of 24 to 18. So let's go ahead and do 24 over 18. I don't need to worry about this side that I don't know. That's not what they asked me for. All right, and then I need to look at this and say, well, what number, what's the GCF, the greatest common factor of 24 and 18? So 24 and 18, let's see, they both have 2, so I always have that as a fallback, but let's see if there's something bigger. Oh, they both have 3. Okay. Ooh, I know. 6 times 4 is 24, and 6 times 3 is 18. I bet you it's 6, so let's go ahead and look at that. I divide by 6 here and here. I get 24 divided by 6 is equal to 3. Ha, just kidding. testing you to see if you're paying attention. 24 divided by 6 is 4, and 18 divided by 6 is 3. So I get 4 over 3. So I can go ahead and I can write it like that. Okay. But just as a fun note, the order didn't matter on that. So you could have also got 3 over 4 if you created your ratio as 18 over 24 instead. Either one of those works. Okay, so it does not matter which one you choose. All right, down here to the big bad word problem, and then we will be done. Examples of real world scale drawings and similar figures. Things that we would see in the real world. Why am I learning this, Ms. Alfana? Well, you're learning this because you're going to look at things like maps and blueprints and science textbook drawings of cells and other scientific things that are either really small or really big, or indirect measurements. These are all times that you would use this similar figures information. Okay, and so we've got a couple of real world examples here that I'm going to work through with you. Once again, I hope you paused the video and tried this on your own. Even if you didn't get all the way to the end, I hope you tried it because that's really helpful. Max is 6 feet tall. So here's Max, I'm going to assume. And his shadow is 8 feet. So let's start labeling things as we go. Max is 6 feet tall. So I'm going to write 6 feet. His shadow is 8 feet long. Would it make sense to you that there is a connection here between the top of his head and the end of his shadow? Hey, look, I just made a triangle. Okay? He is standing next to a tree that has a shadow that is 24 feet long. How tall is the tree? Oh, so I see this. We're going to use similarity because the sun is going to make the shadows similar of different shapes, which is kind of neat. You can test it. You can actually take yourself outside, measure your shadow, measure a friend's shadow, and see the ratios there and see, hey, that creates similar sizes. So we can do that with the tree here. We've got the same situation. This kind of makes a triangle with the angle of the sun. Okay, and so what we're going to do is we're going to look at this and we're going to figure out which parts are corresponding. So do you think the shadow corresponds with the shadow? Or do you think the height of the tree corresponds with the shadow? Me, I'm looking at this and I think height corresponds with height and shadow corresponds with shadow. So I'm going to create my ratios. And I'm going to put the height here. This is my unknown of x. Okay, put x over, and what is the corresponding height? It's 6 feet. Is equal to, and then on my x I want to stick with the tree, so 24 over, this shadow is 8. Oh, hold on. Let me think. Did I do that right? X, we went height to height. And now we're going shadow to shadow. Okay, so anytime you're like, am I doing these numbers in the right order? I really want you to lock in and go, okay, this is the height. Did I compare it to the height? Okay, yes, I did. This is the shadow. Did I compare it to the shadow? Okay, yes, I got that. So now I can do my cross multiplication. I get my 8x. Okay, so I'm multiplying diagonally. 8 times x is equal to 6 times 24. So I get 8x is equal to, let's see, 6 times 4 is 24, carry the 2, 6 times 2 is 12, plus 2 is 14, so I get 144. I'm going to divide by 8 on both sides. So see, sometimes I use the calculator, sometimes I choose to stretch my brain and make sure I remember how to do things. 14, 8 goes into 14 one time with 6 left over. 8 goes into 64 8 times, so that's 16. And you can always do the mental math, and then if you're just like, I don't know, I'm tired, let's make sure it's right, I can go back and do 144 divided by 8 and just double check. Okay, oh my gosh, I wrote 16 even though I said 18 out loud. So even though I did it right, I got distracted and I wrote the wrong thing. So don't think, oh, I'm good at mental math, I don't need to check my work. Look at that, I just caught a silly mistake. Okay, all right, so then x is equal to 18 what? So let's see, he was 6 feet tall, 6 feet. Okay, so this tree must be 18 feet tall. So I'm going to smush it down on the bottom and I'm going to say the tree is 18 feet tall. And put a period at the end because I know my basic sentence structure. Yay! Alright, and last but not least, the map has a scale of 2 centimeters to 6 miles. So that means that every 2 centimeters on the map is 6 miles in the real world. Dallas to St. Louis is 210.3 centimeters. That is a very lot of 2 centimeters. Okay, apart from on the map to the nearest mile, how far apart are they in the real world? So we're going to do centimeters to miles. So I'm going to turn this to 2 centimeters to 6 miles is equal to my 210.3 centimeters to I don't know how many miles. Hey, look, now I've got a ratio. I'm going to solve it the same way. 2 times x is 2x. 6 times 210 and 3. I don't know what that is. Let's check. I could do it mental math, but we're running out of time. So let's do 6 times 210.3 equals, oh, good Lord, that's 1,261 and 8/10 is equal to 2x. I'm going to divide both sides by 2. I've still got that number on my calculator, so I can just do divided by 2 equals, and I get x is equal to 630 and 9/10 of it, and I have to think about I was doing miles, so that would be miles. So I can say that Dallas and St. Louis are 630 and 9, let's see, to the nearest mile. Oh, they wanted us to round it. Good thing we caught that because that would be wrong on a computer program. It says to the nearest mile, so that's the whole number. So this is 0.9. So I'm going to round up here because 5 and up says to go up. So that's actually, they want 631. So see, we gotta always read things carefully because it's easy to like go, okay, I did the math and then miss details. So I always go back and read it again. It's also a good reason why not to use pen. So let's go back and read what I was saying. Dallas and St. Louis are 631 miles, say, apart. Okay, and there we go. We are done with our notes. Hopefully this helped. I'll see you in class. Have a great day.